All right, today we are going to start chapter 4. Now, chapter 4, we are actually going to split up into 3 parts. So for this first part, we're only going to do sections 4.1, 4.2, and 4.3. So we're going to go over 4.1 today. You will need a calculator for chapter 4. Absolutely will have to have a calculator. And for this chapter, you do need to make sure that your calculator is in degree mode. If you are using the blue calculators from class, those are automatically in degree mode by default. If you are using a graphing calculator or any other calculator, you may possibly need to put it in degree mode. So if you are using a regular graphing calculator like the TI-84, you are going to need to hit the mode button, which is right next to second. And then once you hit the mode button, you will go down to where it says radian and degree. Yours most likely has radian highlighted. You will need to go over to degree and hit enter. That way degree is highlighted and your calculator will be in the correct mode. Then you can quit out of that and you should be good to go. But you do have to have your calculator in the correct mode. All right, so what we're going to be looking at today is right triangle trig. And a lot of this you guys did in geometry. But we're going to add a little bit more to it and review what you've already done. So we have the basic 3 trig functions that you guys did in trig, and those are going to be your sine, cosine, and tangent. Now, most of us learned SOHCAHTOA in geometry. So we have and TOA. So SOHCAHTOA. So that stands for sine is opposite over hypotenuse. And so here we go, sine, which is abbreviated S-I-N. No, it is not sin, it is sine. And sine is opposite over hypotenuse. Then we have cosine is adjacent over hypotenuse. So cosine, which is abbreviated COS, and that is adjacent over hypotenuse. And then the last one is tangent. Tangent is opposite over adjacent. So tangent, abbreviated TAN, is opposite over adjacent. So those are the main 3 that you guys learned years ago. Now we're going to take a look at the inverse functions for that as well. So if we look at the inverses, the inverse or reciprocal function. The reciprocal of sine is cosecant. And we know that reciprocal just means flipped over. So if cosecant is the reciprocal of sine, and sine is opposite over hypotenuse, then that means cosecant is hypotenuse over opposite. Cosecant is abbreviated CSC. Then the reciprocal of cosine is secant. It's abbreviated SEC. And if cosine is adjacent over hypotenuse, then that means secant is hypotenuse over adjacent. And then the last one, we have the reciprocal of tangent. So the reciprocal of tangent is cotangent, and it's abbreviated COT. And so if tangent is opposite over adjacent, then cotangent is adjacent over opposite. Now, I don't necessarily have to have you able to rattle these off to me. What I do need you to be able to tell me, though, is you need to know that sine is opposite over hypotenuse. You need to know that cosine is adjacent over hypotenuse. You need to know that tangent is opposite over adjacent. You need to be able to list those off and know them like the back of your hand. Then we want to learn that sine and cosecant are reciprocals. We want to learn that cosine and secant are reciprocals. And tangent and cotangent are reciprocals. Because that way, if we learn the main 3 and we know what their reciprocals are, then all we have to do is flip over that answer. Now, we have all this talk about opposite, adjacent, and hypotenuse, but we need to make sure we understand where those come from. Now, hypotenuse is always, always, always the longest side of a triangle, and it is always across from the right angle. So if my right angle is here, then that means directly across the triangle from that will be the hypotenuse. So that will never ever change. Hypotenuse is always directly across from the right angle. Now, what can change though is your opposite and your adjacent. Those are based on what angle it is that you're using. So we have this angle labeled as theta. So that's just kind of like a variable they use for angles. There are other ones as well, but theta is a pretty common one. So if we have this angle labeled as theta, that's the angle we're using. So we have to label the other two sides based on that angle. So across from that angle, that is always going to be our opposite side. Then if we have the hypotenuse labeled, we have the opposite labeled, then that means the other one has to be the adjacent. Okay? So that is true if that angle is the one we're doing as theta. However, let's say that we did this one as theta. Then that means across from that, this would now be the opposite, which means this would be the adjacent, but the hypotenuse still did not change. So always label your sides based on what angle it is that you're using. So if this is our angle, then that means this is our opposite, this is our adjacent. And hypotenuse is always across from the right angle. Okay, so once we have those down, we are going to take a look at one problem. All right, so we want to find the exact values of the 6 trig functions of theta. So theta is right here. So this is the angle that they have labeled as theta. So we want to go ahead and label our hypotenuse first because that one always the same. So our right angle is here, and across from that, that means this is going to be my hypotenuse. All right, so then the next thing we'll do is label our adjacent and our opposite. So since theta is in this bottom left corner, we go directly across the triangle, and so that means that 8 is going to be my opposite side. Therefore, the only other side I have left is down here, so this one is going to have to be the adjacent. Now, they gave me a side length for the opposite and for the hypotenuse, but they did not give me a side length for the adjacent. So I'm going to go ahead and find that because I know that in order to find my 6 trig functions, I have to know the length of the opposite, the adjacent, and the hypotenuse. So I need a side length for all 3 sides. Well, because this is a right triangle, that means that we can simply use Pythagorean theorem. We know that Pythagorean theorem is a squared plus b squared equals c squared. We know c squared always has to be the hypotenuse. A and b are the other sides. It doesn't matter which one is which. So I have my opposite is 8, so we're going to say 8 squared, plus I don't know my adjacent, so that's going to be my b squared, and it's going to equal c squared, so that's my hypotenuse, 17 squared. And so then we do the math for this. So we have 8 squared is 64, and then we have our plus b squared, and then we need to do 17 squared. So on our calculator, 17 squared is 289. Now we have to solve for b. So the first thing we do is get b squared. So we're going to subtract that 64. So if I subtract 64 from both sides, then that's going to give me 225. And then I take the square root of both sides. And so then this is going to give me b equals a nice, neat 15. Now, technically, when we take the square root of both sides, we're supposed to do plus or minus. However, we're finding a side length here, which means our side length is not going to be negative. Therefore, I'm not bothering with the plus or minus. It's just 15. So we have that the adjacent is 15. So that's great. Now I want to start working on my 6 trig functions. I always start with the original 3, and I always put them in the exact same order. So I'm going to start with sine, then I'm going to do cosine, and then I'm going to do tangent. And you should always follow those with whatever your angle is. So in this case, it's theta. So sine theta, cosine theta, and tangent theta. So then from there, I'm just going to set up the fractions with those side lengths. I know that sine is opposite over hypotenuse. So the opposite side is our 8. The hypotenuse is our 17. And then I double check and make sure that fraction can't be simplified, which it can't, so I move on. Then cosine I know is adjacent over hypotenuse. So we found that the adjacent was 15, our hypotenuse is 17, and again, that fraction cannot be simplified, so we move on. Then tangent is opposite over adjacent. So the opposite side is 8, the adjacent side is 15, and again, that fraction cannot be simplified, so we move on. So we have our main three. Now we want to do the reciprocals. So the reciprocal of sine is cosecant theta, and since it is the reciprocal of sine, that simply means we're going to flip that answer over. So instead of 8 over 17, we have 17 over 8. We already determined that 8 over 17 can't be simplified, so 17 over 8 should not be able to simplify either. Next, we do the reciprocal for cosine, which is secant theta, and we take the answer for cosine and we flip it, so that gives us 17 over 15. Again, cannot be simplified. Then we do the reciprocal for tangent, which is cotangent theta, and we flip that answer. So instead of 8 over 15, we have 15 over 8, and again, cannot be simplified. So the big thing is remembering what sine, cosine, and tangent are, and remembering that the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. It's tempting to want to put sine with secant and cosine with cosecant because we've got SS and CC, but we can't do that. So sine goes with cosecant, S goes to C, cosine goes to secant, C goes to S. So there's always an S and a C together. And then tangent and cotangent sound like they belong together, so that one is easy. All right, so once we have our 6 trig functions, then we're done. Now, it does say exact value, which means I do not ever, ever, ever want to see a decimal here. I want fraction answers. If you give me decimal answers, I'm going to mark them wrong. Exact values mean I want fractions in simplest form. All right, so moving on, we have one that is very similar. So we do have to fill a little bit of information in on our own, though. We have a triangle. It's just a random triangle that I've drawn. It says if cosine theta is 2 over 5, we want to find the exact values of the 5 remaining trig functions for the acute angle theta. Okay, so let's start with going ahead and labeling those sides. Well, we know we have our right angle. Across from that is going to be our hypotenuse. That's great. Then next we have our theta. So since theta is here, that means across from that will be the opposite. And therefore, the third side has to be the adjacent. Now we can fill in a little bit of information. Not a ton, but we can fill in a little. So what we want to look at next is, we know that we're trying to get the 6 trig functions. So I'm not going to worry about which one they gave me. I'm just going to write it out the same way I did in number 1. I'm going to do my sine theta, then I'm going to do my cosine theta, then I'm going to do my tangent theta. Once I have those, then I'll do my reciprocal functions. Now, they've given us one of them. They have given us cosine. Now, to fill these in on the triangle, this is going to give us 2 pieces of information. So we've got to be able to remember that cosine is adjacent over hypotenuse. So that means this fraction is a simplified fraction of the adjacent over the hypotenuse. So even though that fraction is simplified, it still gives us a ratio. So we're just going to use those numbers because we want the simplified fractions in the end anyway. So for our adjacent then, we're going to have 2. For our hypotenuse, we're going to have 5. And so then we need to find what the opposite is. So again, we're going to do our Pythagorean theorem to find that. So then, again, we know that hypotenuse has to be the C. The other 2 are A and B. Doesn't really matter which one is which. So I don't know my opposite, so I'm going to put A squared plus my B squared. So my B is going to be my adjacent, so that's 2 squared. And that's got to equal my hypotenuse squared. So then I have A squared plus 4 equals 25. Then I need to subtract 4. So a squared will give me 21. And then I need to take the square root. Well, the square root of a squared is simply a, but the square root of 21 is not something that I can simplify. Therefore, it just remains the square root of 21. We will not change it to a decimal. We're going to leave it as the square root of 21. Now, if that radical could be simplified, we would have to do so. So you would look for, is there a perfect square that I can divide evenly into 21? If so, we can simplify that radical. If not, we can't. So we can't divide 4 in. We can divide 1, but it doesn't do anything. We can't divide it by 4. We can't divide it by 9. We can't divide it by 16. And then 25 is too big. So there are no perfect squares that divide evenly into 21. So we are just going to leave that as the square root of 21. All right, once we have that, then we can go ahead and start doing our 6 trig functions. So sine, we know, is opposite over hypotenuse. So our opposite is going to be our square root of 21 over our hypotenuse, which is 5. Now, even if I could divide 21 and 5, I can't because one's in the radical, one's not. So unless we were to have a number out here that could simplify with 5, then that can't be simplified at all. And so we just leave it the way it is. Then for our cosine, we know that is adjacent over hypotenuse. So adjacent was 2, hypotenuse is 5. And that's the one they gave me, so we should be able to get that one right. And that also cannot be simplified. Then tangent is opposite over adjacent. So our opposite is the square root of 21 over our adjacent, which is 2. And that as well cannot be simplified. So those 3 are done. Now we have to do the reciprocal, and this is where we're going to have to do a little bit of extra work. So the reciprocal of sine is cosecant theta. And so we flip that fraction over, and we have 5 on the top. We have the square root of 21 on the bottom, but we are not allowed to leave the radical in a denominator of a fraction. So that means that we have to rationalize this. So in order to rationalize, we need to take that radical, simplify it if it can, but we already determined that's not possible. And we are going to multiply both the top and the bottom by that radical that we need to get rid of. By doing so, that is going to give us 5 square root of 21. So those are just multiplied together. And on the bottom, that's going to give me just 21. Because if I'm squaring something, or I'm multiplying something times itself, that means I'm squaring it. So if I'm squaring a square root, those are going to simply cancel and leave me with 21. So that would be the simplest radical form for our cosecant. Now, for cosine, it's a little bit easier. So the reciprocal of cosine is secant theta. And so when we flip that fraction over, we get 5 over 2, and that's fine the way it is. No radicals there. Then for tangent, the reciprocal of tangent is cotangent theta. And when we flip that fraction over, we get the 2 on top, square root of 21 on the bottom. And so again, we can't leave a radical in the denominator of fraction, so we multiply by that radical we want to get rid of. And so then this gives us 2 square root of 21 over 21. Now, to simplify your fractions, because sometimes you'll be able to simplify just a little bit more, you will need to look at the numbers that are not in the radical. If those numbers can be simplified, you must simplify them. In this case, they can't, so we can't do anything. Same thing down here. You must look at these numbers outside of the radical. If those can simplify, we've got to do it. These can't, so we're done. All right, so it is very common to forget to simplify some of these radicals, so be very careful with that. Okay, so now, let's go ahead and take a look at our next one. This one is the same as the last one, except the one they've given us to start with is tangent. So I would recommend pausing the video, try to do this one on your own, and then kind of see how you do, and then turn the video back on and make sure that you've got the correct answers. So what we want to look at here is, go ahead and get this labeled. So if our right angle is down here. Then across from that, we've got the hypotenuse. Then, since this is the theta that has been labeled, that means across from that is our opposite, and therefore the third side is our adjacent. All right, so then let's put in what we've got. So we have tangent, and we need to remember that tangent is opposite over adjacent. So that means that 1 is our opposite and 2 is our adjacent. So 1 for the opposite, 2 for the adjacent. So that means that we have to find the hypotenuse this time. So that means we do not know C. We know A and B, we do not know C. So we are going to do 1 squared plus 2 squared equals whatever C is squared. So then we've got 1 plus 4 equals C squared. So then we just add these together this time. That gives us 5. And then when we take our square root on both sides, the square root of 5 cannot be simplified, so we just leave that as the square root of 5 for C. So then this is simply the square root of 5. And then we can go ahead and do our 6 trig functions. So we start with our sine theta, then we do our cosine theta, then our tangent theta. So sine theta is opposite over hypotenuse, so our opposite is 1. Our hypotenuse is square root of 5. We cannot leave a radical in the denominator, so we would multiply top and bottom by that radical that we want to get rid of, which is square root of 5, and that will leave us with 1 square root of 5, which is just square root of 5, over regular 5. Then for cosine, that is adjacent over hypotenuse. So our adjacent is 2. That goes over our hypotenuse, which is square root of 5. So again, we have to rationalize that denominator. So you multiply both top and bottom by the square root of 5. And that gives us 2 square root of 5 over regular 5. Now, rationalizing denominators is something that we're going to be using a lot for a while. So we need to make sure that we're able to do that really quickly. You want to be able to look at something like this and just automatically be able to tell me that it's going to rationalize to be that. It's something we want to be able to do super quickly, super easily. All right, then we have our tangent. Our tangent is opposite over adjacent, so that's 1 over 2. That's the one they gave us. Now, when we go to do our reciprocal functions this time, we're going to want to do this smart. So the reciprocal of sine is cosecant, switch my letters, cosecant theta. Now, when I go to flip my fraction, I know I need to flip the answer for sine, but think about it. If I were to flip this fraction, then I would get 5 over square root of 5, which means I would have to rationalize, and then I would end up having to simplify. However, if I go back and I flip the answer before I rationalized, that will save me some work. If I flip that one, then I get the square root of 5 on the top, 1 on the bottom, and that doesn't have to be rationalized now. I can just write it as the square root of 5. Now you'll get to the same answer the other way. It's just going to take you more work, because if you do this one, I'll change colors. If you were to flip that one and do 5 over the square root of 5, then that means you have to multiply top and bottom by square root of 5, and therefore this becomes 5 square root of 5 over regular 5, and then you've got to cancel your 5, so you still come up with the square root of 5, but it took longer. So if you have to rationalize one of the original 3, then when you go to do the reciprocal of the original, not the rationalized answer. It will just save you a whole bunch of trouble. All right, so now moving on. So we go to the next one. The reciprocal of cosine is secant theta. And so again, this is a rationalized answer. So I don't want to flip that one. I want to flip the original, which would put the square root of 5 on the top, the 2 on the bottom, and good to go there. Then for the last one, the reciprocal of tangent is cotangent theta. And then when I flip that one, I just get 2 over 1, which is just 2. So that gives us our 6 trig functions simplified. So we have sine, we have cosine, tangent, we have cosecant, secant, and cotangent. Alrighty, the next thing that we want to talk about is special right triangles. So what we talked about so far could be used for any right triangles. These are special right triangles, and so that's when we have a very specific relationship between the angles. So our special right triangles are, we have 30, 60, 90, and we have 45, 45, 90. Now, let's start with our 45, 45, 90. We know that if we have two angles that are the same, that means we should also have two sides that are the same, and they should be opposite those angles. So that's why we have x here for both of those sides. Now, the third side is going to be our hypotenuse, and we know the hypotenuse has to be the longest side. So our hypotenuse is going to be whatever those other sides are, x, times the square root of 2. So if we've got these as nice, neat numbers, let's say this is 3, then that means this would simply be 3 times the square root of 2. That's nice and easy. Where we have to be careful is if we've got just a normal number here, let's say this is 5. Well, if I'm going to get what this is, well, to go from this side to this side, I multiplied by the square root of 2, which means to go back, I need to divide by the square root of 2. So that would be 5 divided by the square root of 2, which we would have to rationalize to be 5 square root of 2 over regular 2. So we're going to have to do some rationalizing again, and so we've got to be able to think about these things. So with that in mind, let's look at our 30, 60, 90. So for this one, we have 3 different angles, therefore we have 3 different sides. We have 30 degrees is our smallest angle, so across from that is our smallest side. Then 60 degrees is going to be the medium angle, the one in the middle, and so across from that is going to be the medium or the middle side. And then we have our right angle, and so across from the right angle is going to be the longest side. So across from the biggest angle is the biggest side. Now, we want to be familiar with the relationships here as well. So we have our shortest side is going to be x. Then our hypotenuse, our longest side, will always be double that. So whatever that short side is, multiply it by 2, that gives us our hypotenuse. If we want the other leg of the triangle, not the hypotenuse, but the other leg, then we take whatever this shortest side is and we multiply it by the square root of 3. So those are going to be our relationships between those sides in these special right triangles. Now, we can use this, and we're going to go ahead and take a look. We're going to start kind of working our way towards some stuff we're going to learn in 4.3. But let's say for both of these that I had a hypotenuse of 1. So if my hypotenuse is 1 here, well, we know the hypotenuse is twice as long as the short leg, which means that the short leg is half of the hypotenuse. So that means x would have to be 1/2. Now, the long leg here is going to be whatever x is, 1/2, times the square root of 3. So if I do 1/2 times the square root of 3, which is technically over 1, then this is going to give me square root of 3 over 2. So we want to kind of remember those. Those are going to come up again when we go over 4.3, so kind of keep those in mind. Now let's take our 45, 45, 90 triangle, and let's say here that we also have a hypotenuse of 1. Now, we said that if this was a whole number, in order to get the x, instead of multiplying by the square root of 2, we're going to have to divide by the square root of 2, which means that would give us 1 over the square root of 2, which rationalized would be 1 times the square root of 2, which is just square root of 2, over regular 2. And then we know that these two sides have to be the same, so if one of them is the square root of 2 over 2, then the other one has to be the square root of 2 over 2. Now, this is true if I have a hypotenuse of 1. If the hypotenuse is anything other than 1, then that's going to change these sides. All right, so now with that in mind, let's take a look at here. So we want to find the exact value of sine 30. Now, they don't give us any side lengths, but given this information, we can take those and we can create a ratio using these numbers. Even though those may not be the same, the actual side lengths, they are a simplified version of that ratio. So the ratio will hold true, even though the side lengths may actually be longer. So if we've got sine of 30, well, the first thing we have to do is make sure we label correctly. So we know this has to be our hypotenuse. Since we are using the 30-degree angle, then that means across from that would be our opposite. And then the other side then would have to be the adjacent. Now, we're finding sine, and sine is opposite over hypotenuse. So if we go to our triangle, we labeled our opposite with a side length of 1/2, and then our hypotenuse is 1. Well, 1/2 divided by 1 is simply 1/2. And so regardless of what the side lengths actually were, because they have to have this same relationship, then that means that no matter how long or how big or how small, it's always going to simplify. Sine of 30 degrees will always simplify to be 1/2. All right, now let's do the tangent of 45 degrees. So using our 45, 45, 90 triangle, tangent we know is opposite over adjacent. And so opposite and adjacent, well, if we're looking at our triangle, we have two angles that are 45 degrees, so I just need to pick one. So let's say we just use this one. So we know across from the right angle is our hypotenuse, across from our labeled angle is our opposite, and so then the other one has to be the adjacent. Well, in a 45, 45, 90, the opposite and the adjacent are going to be identical, always, always, always. So in this case, we had square root of 2 over 2 for both of these. So if my opposite is square root of 2 over 2, and I divide it by the adjacent, which is also square root of 2 over 2, then that's something divided by the exact same thing, so that is going to come out to be 1. And so again, regardless of how big or small the triangle is, those relationships are always going to hold true. So tangent of a 45-degree angle is always, always going to be 1. Always. All right, now let's look at some that are a little bit more concrete. We've got actual lengths to do here. So we want to find a missing side length. So we're going to have to do a little bit of math, and this is where your calculators are really going to come in. Up until now, we haven't really used them except for maybe, squaring a larger number. But we're going to have to use them now. So we're going to find the missing value of x. So for number 1, this is the number that we need to find, x. Then we're going to look at what we have and what we're trying to find. So we know that we are using a 42-degree angle. So whatever trig function we use, it's going to be that trig function, 42 degrees. And then we have 18. We need to know x. So let's get our triangle labeled first. We start with our hypotenuse, which is always across from the right angle. So this has to be our hypotenuse. Then next, we want to do our opposite. So since we're using the 42-degree angle, because that's the one they have labeled, that means across from that is going to be our opposite. Therefore, this side has to be the adjacent. Now, I have two pieces or two sides that I either know or need to know. So I've got my 42-degree angle, I have my hypotenuse, and I need to know the adjacent. I don't know what the opposite is. I don't need to know what the opposite is, which means I will not be using the opposite. So I want to choose a trig function that uses these two sides, hypotenuse and adjacent, and I do not want to use the reciprocal functions. I want to use those main three. So for those main three, if we remember, SOHCAHTOA. Then for hypotenuse and adjacent, that's going to be this one. So I want to use cosine. So I'm going to do cosine of my angle, which is 42 degrees, and that is going to equal my adjacent, which is x, over my hypotenuse, which is 18. Now, if I want to solve for x, then if I think about it, if I want x by itself, I could really just multiply by 18 to get rid of that 18, and that would take care of my problem. So if I multiply one side by 18, then I have to multiply the other side by 18. And so these 18s cancel, and then I have that x is simply 18 times cosine 42. And so this is where I plug it in my calculator. Now remember, regardless of what kind of calculator you're using, make sure that it's in degree mode. And then you're just going to literally type in 18. You're going to hit the cosine button, and then 42. Close your parentheses, and you get a pretty long decimal. You should have 13.3766, so forth and so on. Now, we are going to have a pretty standard rule for this, that side lengths are going to be rounded to the nearest tenth. So that means if we round this to the nearest tenth, it's going to come out to be 13.4. So we are going to round side lengths to the nearest tenth. We are going to round angles to the nearest whole number, the nearest degree. So then we have found the value of x, and that is all they asked us to find. So moving on to number 2, we're going to do pretty much the same thing. So let's start by labeling our triangle. So we have across from the right angle, this is going to be my hypotenuse. Now, I notice that it's not labeled, and it's not what I'm trying to find, which means I am not going to use the hypotenuse, but I'm going to go ahead and label it for now anyway. Then, I am using the angle 21. So if this is the angle I'm using, then across from that is going to be the opposite, and that means that third side has to be the adjacent. Okay, so I know nothing about the hypotenuse. I am not trying to find the hypotenuse, so I do not want to use the hypotenuse. I am only using adjacent and opposite, and so that is going to be tangent. So we are going to do tangent 21, because that's the angle we're using, and that is going to equal the opposite, which is 9, over the adjacent, which is x. Okay, now for this one, if I'm wanting to solve for x, I can't multiply by 9 to get rid of 9 because 9 is on the top. But I can get x out of the bottom by multiplying by x. That won't completely solve it for me, but it's a good start. So if I multiply by x on one side, then I multiply by x on the other side. So then I have x times tangent 21, and that is now going to equal just 9 because those x's would cancel. Now, since this is x times tangent 21, now if I want to get x by itself, I can just divide by tangent 21. So make sure that we do it on both sides. And so the tangent 21's cancel, and we have that x is 9 divided by tangent 21. All right, and then we can type this in our calculator as well. So making sure it's in degree mode, then we're going to do 9 divided by, we're going to hit the tangent button, and then 21, close our parentheses, and we should get 23.4458 and so forth. Now, since we are finding a side length, we are rounding to the nearest tenth, so that is going to be 23.4. And that is what we were asked to find. All right, so that is finding a missing side length. Now, we may also be asked to find a missing angle. So remember, missing angles, we're going to round to the nearest whole number, or the nearest degree. And we're going to use these same formulas, sine, cosine, and tangent, but we're going to be solving for an angle this time. So we're going to have to do things just a little bit different, but it'll start out the same. So we're going to start by labeling our triangles. So across from our right angle, we have hypotenuse. Then we have the angle that we're using, theta. So across from theta is our opposite. and that means that this third side has to be the adjacent. Okay, once we have all of that labeled, then again, just like before, we're going to figure out which function we need to use. So we don't know anything about the hypotenuse. We're not trying to find the hypotenuse. We are only using the adjacent and the opposite. So just like on the last one, that is going to be tangent. Now, we don't have an actual angle measure though, so we're just going to put tangent theta equals the opposite, which is 26, over the adjacent, which is 11. Now, we need to find the angle. So I can't just multiply and divide to move things around. Tangent theta is a single unit. I can't do anything to separate that. What I need to do is to solve for theta. So when I am trying to find an angle, in order to solve for that angle, you are going to use the inverse operation. So we are going to do inverse tangent of whatever that fraction came out to be, 26 over 11, and that is going to tell us what our angle is. Now on the calculator, in order to do inverse tangent, you are going to hit second, then the tangent button, and you should see that tan with the little -1, and it opens a parentheses. And in the parentheses, you are going to type your 26 divided by 11, close your parentheses, and hit enter. And you should get 67.06789, blah, blah, blah. Now remember that angles are going to get rounded to the nearest whole number, or the nearest degree. So that is going to round to just give you 67 degrees. And so that is all we needed to find, was theta. All right, so remember, for this, you are going to hit second and then tan, and then type in your fraction. All right, so for number 2, it's going to work the same way, except we're going to use a different trig function. So across from here, we have the hypotenuse. And why don't y'all go ahead and pause the video, work this one, and then turn it on and make sure you've got it. And I'll go ahead and finish it out for you. So if you've got your hypotenuse, then the next thing we want to do is label our opposite. So we have the angle we're using is here. So across from that is our opposite, which means the third side is our adjacent. Okay, so then we can look at what we have and what we're finding. So we do not know anything about the adjacent, and we are not asked to find the adjacent, so we're not using that one. The only two sides we're using are hypotenuse and opposite, so that is going to be sine, because sine is opposite over hypotenuse. So we have sine of theta, whatever theta may be, and that is going to equal the opposite, which is 5, over the hypotenuse, which is 12. Now, since we're asked to find theta, then in order to find theta, we are going to do inverse sine of that fraction, 5 over 12. So second sine 5 over 12, type that into your calculator. And we get 24.6243, blah, blah, blah. And then, since we round angles to the nearest degree, that is going to come out to be simply 25 degrees. Please make sure that you put the degree symbol on there, because without the degree symbol, it's not an angle. It's just a measurement. All right, so we've got a few more problems to do, and we will be done for the day. We've got a couple word problems to do, and then we have one more thing, one more concept that we're going to need to talk about. So, a competitor in a triathlon is running along the course shown. Determine the length in feet the runner must cover to reach the finish line. All right, so we are having to find this distance right here. So we know that if we created a right triangle out of that, then we have a 63-degree angle here. We know that this distance is 200 feet. We want to find this distance. So really, we're just using trig here in a right triangle. So let's go ahead and label what we've got. So we have across from our right angle, that's going to be our hypotenuse. So that's what we're having to find, is our hypotenuse. Then we know that across from the angle we're using, which is 63, so across from that should be our opposite. We're going to be using that, and so the third side has to be the adjacent. Well, we don't know anything about the adjacent. We're not asked to find the adjacent, so we're not going to use the adjacent. We're going to use opposite on hypotenuse, which again is sine. So we're doing sine of the angle, which is 63, equals opposite, which is 200, over hypotenuse, which is x. And so you're going to solve this just like we did a few problems ago. I would multiply by x first. And so then this would give me x times sine 63 equals 200. But then we've got to divide both sides by sine 63. And then we can put that in our calculator. So x will equal 200 divided by sine 63. So in your calculator, 200 divided by, I hit the sine button, 63, close my parentheses, and I get that my hypotenuse, x, is rounded to the nearest tenth, 224.5. And since they do give me a unit of measure, I want to go ahead and include that in my answer. Alrighty, so let's take a look at another one similar to that. Now this one has a little extra something that we have to be careful with. So it says a ground crew worker who is 6 feet tall is directing a plane on a runway. If the worker sights the plane at an angle of elevation of 32 degrees, what is the horizontal distance from the worker to the plane? So we are finding this horizontal distance right here. That's what we need to find. Now, it talks about a 32-degree angle of elevation. That means, angle of elevation means that from your horizontal line of sight, so from your eyeballs, looking up, that's that angle. So this angle right here, looking up to the plane, is 32 degrees. Now where we have to be careful with this is that this horizontal line of sight is 6 feet off of the ground because our guy is 6 feet tall. So once we find this, then the total height is adding 6. So they're telling us that this height, that the height of the plane is currently 150 feet, but if our worker is 6 feet, then that means that from our line of sight up to the plane, that is only going to be 144 feet, because we've got to do 150 minus 144. So we've got 144 plus 6 for the 6 foot tall guy. That gives us our total of 150 feet. So you've got to be very careful there. So when you're doing your triangle, this side of the triangle is only 144, not 150. All right, so we've got our right triangle here, and we have our 32-degree angle. So then we can go ahead and label what we've got. So our right angle is here. So that means this is my hypotenuse. I have my 32-degree angle, and across from my 32-degree angle is my opposite. So my opposite is 144, and my adjacent is the side that I'm trying to find. So I don't know hypotenuse, I'm not finding hypotenuse, so I'm not using hypotenuse. I'm only using the opposite and adjacent, so that is going to be tangent. Now our tangent, we're doing tangent of 32, and that is going to equal our opposite, which remember, we want the height of the triangle, not the height of the plane, so that is 144 over adjacent, which is x. So we're going to solve this one the same way we did the last one. We're going to multiply by x, so that's going to give us x times tangent 32 equals 144, And then we're going to divide by tangent 32. So x is going to be 144 divided by tangent 32. And we're going to type that in our calculator. So we have 144 divided by, hit the tangent button, 32, close our parentheses, and we get that that is approximately 230.4, and then this was measured in feet. And there we go. Okay, so we have one last problem, and the wording is really kind of everything here. So for this last problem, it tells us to solve the right triangle. We're going to round sides to the nearest tenth and angle measures to the nearest degree. So just like the other ones. Now, what we have to understand though is that when it says solve the right triangle, that means you need to find anything that is not already given to you. By the time we're done, we have to know the length of all three sides, and we have to know the measure of all three angles. Now, since they have given us two angles, because we know that we have a 90-degree angle here, we have a 35-degree angle here, the easiest thing to find is going to be the other angle. Now, I'm going to go ahead and make a list of everything I need to find. So for angles, the only angle I need to find is y. So I need angle y. Then I know side xz, but I do not know side zy, or we can just write that as x because they have labeled it as x. So we will need to find little x, and we will need to find little z. Those are the three things I need to find. Once I have that, I will have all of my answers and I will be done. So there's my little answer box. Now let's go in here and find what we need to find. So we said the angle is going to be the easiest thing to find because we know in any triangle, all three angles have to add up to be 180. Well, since one of these is 90, that means the other two have to add up to be 90. So I could add the two I have and subtract from 180, or since I know this is a right triangle, I could just do 90 minus 35. Either way, we're going to get the same answer. So 90 minus 35, and that is going to give us 55. So we have our first answer. Angle y is 55 degrees. Now I want to find side lengths. So to find side lengths, I'm going to have to do the trig. I'm going to have to use my 35-degree angle. I would not use my 55-degree angle just in case you make a silly mistake and you've got the wrong number down there. If you use the wrong number there, then it's going to give you the wrong number. So I would use the numbers they gave you as much as possible. Try to avoid using your own answers if at all possible. So let's go ahead and find our side x first. So if we have, let's see, we know 10. So that is going to be, let's see, we've got, label our triangle, across from the right angle, this is our hypotenuse. Then across from the angle we know, that's the opposite, which means this has to be the adjacent. Okay, so then looking at what we have, we are finding the opposite, we know the adjacent, which means for this one we are not using the hypotenuse. So opposite and adjacent is tangent. So we're going to do tangent of 35 equals the opposite, which is x, over the adjacent, which is 10. Now for this one, I can just multiply both sides by 10, and that gets x by itself. So this one is nice and easy. So x is going to simply be 10 times tangent 35. So type that in your calculator, 10, hit the tangent button, 35, and we get that x is going to be 7 point, and we get 0.00207, so forth and so on. Now, this brings up another thing that I want to make sure that we're aware of. We know that side lengths have to be rounded to the nearest tenth. Well, if we do the nearest tenth here, then that's going to stay 7.0. I need for you guys, if it is a rounded answer, you need to put 7.0. That 0.0 tells me that it is rounded. It is not exact. If you just tell me 7, you're implying that it came out to be exactly 7. And it is not exactly 7. It is rounded to 7. So you need to put the 7.0. That is important. Now, to find our last side, we have two options. We could do trig again, and if we choose to do that, then we would be using our z, and then since I don't want to use my own answers, I would be using the 10 again. So I'd be using adjacent and hypotenuse, which would be cosine. So I could do that. I could do cosine 35 equals adjacent, which is 10, over hypotenuse, which is z, or since I now know two of my sides, I could go ahead and do Pythagorean theorem. Now, it may not come out exactly the same because this is a rounded answer, but it should come out close. I'm going to go ahead and try to avoid using my answer, so I'm going to go ahead and do trig again. So if I do that, then I'm doing cosine of 35 equals my adjacent, which is 10, over my hypotenuse, which is z. So that means I need to multiply both sides by z, which gives me z times cosine 35 equals 10. And then I need to divide by cosine 35. So z is 10 divided by cosine 35. So I type that in my calculator. And I get that z is approximately 12.2. So I can fill those into my little answer box. X was 7.0. Z is 12.2. And I don't have a unit of measure on this one, so I'm good to go, and that's it. So make sure you read your questions carefully. Does it tell you to solve the triangle, meaning find everything that you don't know, or is it just asking you for one specific piece, one side or one angle? But for the most part, the process is the same for all of them. It's just how much do you need to do. Alrighty, so that's all we have for today. So you guys can start on your homework.